Okay, the first thing I'm going to have you do is look at these three answers and make sure you can rewrite each of these with fractional exponents. There's three different answers, three different answers for each of these. They're easily confused, so remember the parentheses mean everything. So real quick, test yourself. Can I write these with fractional exponents with the correct parentheses? I told him. Okay, let's see if you can get this right on the exam. How would you write this one with fractional exponents? Just shout it out.
3x to the 3 over 2.
3x to the 3 over 2, no parentheses necessary. Correcto. What about this one's the hardest one for people for some reason?
3x cubed in parentheses over 1/2.
Raised to the 1/2 power. Does everybody see why? They're both under the square root, but they have their own powers. This one's the obvious one. They're both raised to the 3/2 power. Okay, good. Here we go. So remember last time we learned if you have fractional exponents, it's the same thing as a radical. Right? Something to a power. So looking at these, if it says simplify, we're going to use whatever method necessary to make our life easier. So look at number 1. It says simplify. If you're not using a calculator, you would say, well, that's the same thing as the cube root of 125. Then that's 25 times 5. 25 breaks down into 5 and 5. So the answer is 5. So we're pulling out groups of 3. Yes? We learned that last time. Okay, this one is the square root of 64, so our answer would be 8. I want you to see that there are two ways to solve this one. There is the properties of exponent way, which means when you multiply the same base, you add your exponents. Base 7 stays as base 7, and then we would do a half plus a half. So our answer is base 7 to the first power. Another way of doing it is to recognize this is the square root of 7 times the square root of 7. Isn't that what that means? So that's the square root of 7 squared, so the answer is 7. Either way, you get the correct answer. Properties of exponents or writing it as a radical. Okay, look at problem number 5. There are two ways to do it. When you multiply the same base, you can add your exponents, agreed? So base negative 5 to the a third plus a third plus a third. That's one way of doing it. Or you could do, that's the same thing as the cube root of negative 5 times the cube root of negative 5 times the cube root of negative 5. Isn't that the cube root of negative 5 cubed?
Yeah.
So it would be negative 5. Well, that makes sense, because look, that's 3/3. Well, that becomes 1. Yeah, he does. Okay, 1 through 30. Start practicing some for 1 through 30. Go. Okay, go to this group with me, 32. So we're going to use properties of exponents for these ones, or we can use radicals when appropriate, but a lot of these are just properties of exponents. So everybody look. Base 81 raised to the 1/4 raised to the 4th. That's raise a power to a power and you multiply the powers. So this is base 81 to the 1/4 times 4, which is 1. Right, everybody? A 4 times 4. 4 over 4? 1. Our answer is 81. Or I could have looked at this as the 4th root of 81 in my parentheses raised to the 4th power. 4th roots and 4th powers cancel out. So we get 81 either way. Now look at this next one, 39. I don't know why we have, honestly, at all levels of math, people have a hard time with properties of exponents. This is super basic. So look, this is y to the first. We're simplifying this. When you multiply the same base, you add. When you multiply, you add. So this is base 2, y to the 1/2 plus 1. Either do it in your calculator, do 1/2 plus 1, math, enter, enter, or do it by hand and get a common denominator. So then we would have 2y to the 3/2. Here's the general rule of thumb. If it starts with fractional exponents, your final answer would stop at fractional exponents. Don't write it as a radical. Looking at this one, it's all time sign. Don't be confused and think that they're connected and nothing can happen here. That's not true. Multiplication can be reordered. That's the same thing as 3 times 4 times x to the 1/2 times x to the 2/3. Therefore, we have a 12, and when you multiply, you add. When you add a 1/2 plus 2/3 in your calculator, hit math, enter, enter, you get 7/6. Or do it by hand. I don't care how you do it. As long as you can get the right answer. Does everybody see? I'm done, because it says we started with fractional exponents, so we end as a fractional exponent. Okay, when you multiply the same base, you add. So when you divide, you subtract. First of all, 12 and 4 divide out to become 3 over 1. 3 over 1. And then when you divide the same base, you subtract, and you always subtract the top exponent from the bottom. So now we're looking at this. 3y to the negative 1/6. Now, we can't have a negative exponent in our final answer, so we need to flip it. Do not flip the 3. 3 has a positive 1 as an exponent. The only thing that gets flipped is this base. So on top is a 3, and on bottom we have y to the 1/6. When I have people say, but Miss Christensen, do I need to rationalize the denominator? Well, once again, if you start with fractional exponents, write it as a fractional exponent. So yeah, it's technically a radical, but if we write it like this, it's all going to be okay. Stop there. Okay, awesome. So do sum in that section, 32 through 61. Now, any base raised to the 0 power is not 0. Any base to the 0 power is 1. Okay, good. So you have your 3 rules. Raise a power to a power and you multiply. Or so when you multiply, you add. When you divide, you subtract. Raise a power to a power and you multiply. So if you want to test your abilities, the harder ones are 47 through 52. Okay, problem number 1, it says multiply. So there's 2 ways to do this one. You could see if it simplifies first, which notice the square root of 4 is 2, times the square root of 25 is 5, so my answer is 10. Another way of doing it is saying, well, that's the square root of 4 times 25. So then 2 and 2, 5 and 5, pulling out groups of 2. So then we would have a 2 times 5 is 10. Just 2 different ways of getting there. So right here, I would first check, do either of these radicals simplify? 3 times 3 times 3. So yes, the cube root of 27 is 3. So then we have the square root of 3 times 3, which is just 3 root 3. If you start with the radical, your answer needs to be in radical form. So done. Okay, look at problem number 7. It says, simplify, and then I'm going to add in, let's use absolute values to practice when necessary. So remember, if you have an even root and your answer has an odd exponent, you put absolute values. So let's simplify number 7. The square root of 36 is 6, correct? We can pull out an x, and then left is the square root of x. So then even root, yes, do we have an odd exponent? 1 is odd, so we'd put absolute values. You don't need to put absolute values under the radical. So we're just practicing using our rule for absolute values. Okay, number 11, this would, the square root of x squared would be a x, square root of y to the 10th, y to the 5th, and then it looks like square root of z would be left. So then you check even root, yes, odd exponent, yes, odd exponent, yes, so you need absolute values around both of those. Because they're both odd exponents. Okay, and while we're on a roll of that, let's go to 19 and 23, and then I'll let you work for quite a while. So with multiplication here, we can reorder this in any order. So I have 4 times 3. Then I have times the square root of 2 times 8, so that's the square root of 16, and then x and x is x squared. And now just simplify it. So we have a 12, and then square root of 16 is 4, square root of x squared is x. So we just have all those things being times together, so 48x. So looking at number 23, they're both cube roots, so let's put them all under the same cube root here. So we have the cube root of negative 9 times 12. I order things together. Then I have x squared and x, so x cubed. Then I have a y to the 4th and a y, that's y to the 5th. And now I'm pulling out groups of 3. So 9 breaks down into 3 and 3, 12 breaks down into 3, and 4, 2 and 2. Pulling out groups of 3 and it's negative. So don't we just pull out negative 3? And then also moving on to my x's, we'll pull out an x. How many groups of 3 are there in 5? 1, so we'll pull out a y. Then left in, make sure you write cube root. Left in is a 2 and a 2, which is a 4. And then also now how many remaining y's? 2 of them. And that would be our answer. Now I have people say, well, does that need absolute values? Is it even an even root? No, so you don't ever need absolute values if it's not an even root. Odd roots? No, never. Okay, so you can basically finish up that the section 1 through 24 on that page. you, telling you. So these are the steps from here on out. When dividing two radicals, put the radicals together first, simplify what's underneath first, and then only if you need to, then rationalize the denominator. You would still get the answer, the correct answer, if you didn't do those steps. It's going to be way harder to get the correct answer. So from here on out, the first thing we do is put our radicals together and simplify under the radicals. So the square root of 75 over 3. Look how much better it is if we do that, because then that makes it the square root of 25. Square root of 25 is 5. Well, wasn't that a lot easier than saying, okay, I need to rationalize my denominator, multiply by root 3, then the top would simplify, the bottom simplifies, then it would all simplify to be 5. That would have been way harder, correct? Follow these steps every time from here on out always. So let's do 26. First thing we do is put the radical together. So 63xy cubed over 7y. Rewrite it in the simplified form. 63 and 7 divide out to become 9. We have x and now we have y squared. So I'm simplifying underneath. So now way easier. What's the square root of 9? 3y. Square roots of x would be our answer. And once again, yeah, that got us the correct answer a lot quicker and more efficiently. Then you can't do it that way. K29. A lot of people will see this on the test and they'll start rationalizing the denominator. Don't. You're not following the steps. Put the radical together first. So we have 4x squared over x. So then from there, well, that would become the cube root of 4x, would it not? So then from there, it already doesn't simplify. Look, you would have got that. Let me just show you quickly. Watch how much longer. I'm going to go through the whole thing quickly. So if you would have rationalized, you would have said, okay, the cube root of x times x is what I need. The cube root of x times x. So then on top, I have the cube root of 4x to the 4th. And then on the bottom, I have the cube root of x cubed. So then on top, I'll pull out an x. Cube roots of 4 is left. On bottom, I pull out an x. So my x's divide out. Oh, an x was left. So then my x's divide out, and I got the same answer. It took 10 times longer. Okay, let's do 32. First things first, put it together. So you have the cube root of 18. Y squared over 12y. Simplify, so that gives you this, the cube root. Look, they both divide by 6. So that becomes a 3, and this becomes a 2. So right now, this is what we have. 3 over 2, and then don't we have a y on top? Now look, we have to stop here and say, okay, unfortunately, we still have a denominator. So we got to split it back apart at this point. So we have the cube root of 3y on top, and on bottom we have the cube root of 2. We have to split it apart because we have a radical in the bottom. And now we'll rationalize. So we want to rationalize by the least amount possible. So we need it to be something cubed, don't we? So don't we need 2 more 2's? Cube root of 2 and 2, and then you can already see there's only 1 3 and 2 2's, so there are no groups of 3 on top. So then 3 times 2 is 12. We have a y. And then on bottom, we have the cube root of 2 cubed. So don't we just have a 2? So that would be our final answer. Simplify first, then rationalize if necessary. Let's do number 38. First, don't rationalize, but divide out what we can. Can't we divide out the x's? So now we're looking at the square root of y over the square root of 3, which is not an appropriate answer. How would we rationalize? Root 3. So on top we have square root of 3y, and on bottom we have the square root of 9, or the square root of 3 squared. So it would become a 3. Rationalizing the denominator on this one is a little bit trickier, but let's tackle it the way we learned last time. So notice nothing simplifies under the radical, so then you would split it apart. So on top we have the cube root of 3a, and on bottom we have this, the cube root of 4b squared c. Now when we rationalize by the least amount possible, we don't want to write 4 as 4. We want to write 4 as 2 2's. Because now we only have to multiply by 1 more 2. Do you guys see how that's better than doing 2 4's? Okay? And then b squared, we need it to be b cubed, so we'll multiply by 1 more b. There's only 1 c, we need it to be c cubed, so 2 more c's is what we need. So now on top, I have the cube root of a 3 times 2, which is 6. I have an a, I have a b, I have a c squared on top. I still have people having a hard time with bottom. Look what we technically have on bottom. I'm writing it right here. We have the cube root of 2 cubed, b cubed, and c cubed. So those cancel out. So we get a 2bc. There's your answer. Follow those steps and it's not too bad. Okay, I want you to do this section 25 through 42. Doing good? Go with me to the next page. Let's add some of these bad boys. Okay. So remember with adding and subtracting, it's a lot more picky than multiplication. They have to be like radicals, and to be like radicals, they have to have the same radical, and what's underneath has to be the same. And if so, then just combine them like terms. 9 root 3s plus 2 root 3s is 11 root 3s, right?
Yeah.
So can we add number 2 together? No. All right, let's look at number 10. It says simplify. Well, we can't add them unless they're like radicals, but we don't know unless we have simplified radicals. So I'm going to pull out of 4 times it to that 3, so that's 12 root 2s. Then 50 is 5 and 10, 5 and 2. So we'll pull out of 5, but we got to multiply to that 2. That's one of the most missed things on the test is people don't put the 2 in front. Times 2, you're there 5. So isn't that 10 root 2s? So then 12 apples plus 10 apples is 22 apples, correct? So 22 root 2s. The apple doesn't change. Now let's look at multiplying out number 19. So let's start distributing. You haven't seen any like this before. So watching back, people. 2 terms, 2 terms. We need to distribute this out. 1 times 2 is 2. 1 times negative root 5 is negative root 5. Negative root 5 times 2 is negative 2 root 5s. Right here is usually where people mess up, so watching carefully. Negative root 5 times negative root 5 is positive root 25. Then from there, isn't root 25 plus 5? So then add 5 plus 2 is 7. So we have 7 minus 3 root 5s. And that would be our answer. So you just got to be careful. It's not like it's hard. It's just easy to make errors. Let's do one more like that, then I'll give you a while to work on that page. 27. We would be breaking the most forbidden of all forbidden rules if we just squared that and squared that, so we would not do that. We would rewrite it as 3 root 2 minus 2 root 3 times 3 root 2 minus 2 root 3. Of course I'm rushing. We've learned this all before, right, everybody? I'd bore you if I went any slower. Let's start multiplying this bad boy out. 3 root 2 times 3 root 2 would be what? 9 root 4. Does everybody see? I'll come back and fix it in a minute. 3 root 2 times negative 2 root 3, negative 6 root 6. Now I've distributed that through. Negative 2 root 3 times positive 3 root 2 is negative 6 root 6 again. Then negative 2 root 3 times negative 2 root 3 is positive 4 root 9. Now really that's 9 times 2. Look, that's a time sign. Don't add in a magic addition sign. So that's actually 18. Then right here we have 4 times 3, which is 12. 18 plus 12 is 30. 30 minus 12 root 6s. So go do that page. Go do some in each section. Okay, notice the problem with 34 is we have radical in the denominator. Here's the problemo. You can't rationalize this like the good old school rationalization because there's 2 terms. If you have 2 terms, the only way to rationalize the denominator is to multiply by the conjugate. So that's a new rule. You have to know that. If there's 2 terms, you rationalize by the conjugate. So to rationalize this, we'll have to multiply by root 5 plus root 2. Root 5 plus root 2. So let's continue this one. So multiplying out the top in pink. 3 times root 5 is 3 root 5. 3 times positive root 2 is positive 3 root 2. Right here, we have negative root 50 and negative root 10 times positive root 2 is negative root 20. Simplify what can. 5, 10, 5 and 2. 4 and 5, 2 and 2. Okay, so that means we had 3 root 5 plus 3 root 2 minus 5 root 2 minus 2 root 5. Combine like terms. 3 root 5s minus 2 root 5s. 1 root 5. 3 root 2s minus 5 root 2s is negative 2 root 2s. That was just the top. Now on bottom, notice what happens. Root 5 times root 5 is root 25. You guys are totally ruining my video back there. Then we have plus root 10 minus root 10. Middle terms cancel out. That's the definition of a conjugate. And then we have minus root 4. So isn't that 5 minus 2? Which is 3. So now look, that took care of the denominator. That made it so there was no radicals. How would I rationalize this denominator? 1 minus root 2. How would I rationalize that? 1 plus root 2. If there's two terms, it's the conjugate. Everybody good? Okay, I want you to do right now the next problem over so you can make sure you understand how to do it. 35. When you get an answer, shout it out. So the answer you should get is root 2 in the end here. Interestingly enough. You can't get